All right, let's settle this once and for all. Can a particle be in two places at once? Does your brain control reality? And can quantum entanglement let you send a text message faster than light? Science fiction loves to make quantum mechanics sound like magic, but the truth? Oh, it's way cooler. You've probably heard that quantum mechanics allows for impossible things. Particles popping in and out of existence, teleportation, parallel universes, and even the idea that reality doesn't exist until you look at it. Sounds insane, right? Well, today we're cutting through the hype and breaking down the biggest quantum myths. And trust me, the real science behind it is more mind-blowing than any sci-fi story. Let's start with the most famous misconception, the idea that a particle can be in two places at once. Superposition, the two places at once myth. You've heard it a million times. A quantum particle can be in two places at once. It's in every pop science article, every documentary, and it sounds completely ridiculous. So is it true? Well, yes and no. Here's the real deal. In quantum mechanics, a particle isn't a tiny solid object sitting in one spot like a marble. Instead, it's described by a wave function, a mathematical function that represents all the possible places that particle could be. Before we measure it, the particle exists in a superposition of multiple possible locations. But the moment we take a measurement, boom. The wave function collapses, and the particle is found in one single location. A good way to think about this is like rolling a die. Before you look at it, the result could be any number from 1 to 6. But the moment you check, you only see one outcome. The die wasn't literally sitting on all 6 numbers at the same time. It just had the potential to land on any of them. That's what superposition really is. Not magic, just probabilities. Wave function collapse. Does reality need you? Now let's talk about a huge misconception. This idea that reality doesn't exist until you observe it. You might have heard that the universe only becomes real when a conscious observer is looking. Some people even take this further and say that your mind creates reality. Sounds pretty mystical, right? But that's not quite how it works. When we say measurement collapses the wave function, it doesn't mean you personally have some kind of magical power to bring the universe into existence. In quantum mechanics, measurement just means interaction. It could be an electron bumping into another particle, a photon hitting a sensor, or any other process that forces the system into a definite state. The universe was doing just fine long before humans showed up to observe it. Think about a vending machine. Before you press a button, any drink could drop. But once you make a selection, the machine locks in that choice, and you get your soda. That's what measurement does in quantum mechanics. It finalizes a result. You're not creating the drink. You're just forcing the machine to choose. Quantum tunneling. Can you walk through walls? Magic portals? Let's talk about another wild quantum idea. Quantum tunneling. You may have heard that particles can teleport through barriers. Some people even claim that if you move fast enough, you could literally walk through a wall. Sounds cool, right? Too bad it's not how tunneling works. Quantum tunneling happens because particles at the quantum level don't have hard edges like billiard balls. Instead, their wave function extends beyond barriers. That means there's a small probability that the particle could be found on the other side, even if classically it shouldn't be able to get through. But this isn't teleportation. It's just probability playing out in a weird but logical way. If you need a simple analogy, think of a beach ball pressed against a stretchy net. If you push hard enough, eventually it pops through to the other side. The ball didn't disappear and reappear. It just managed to get through because the net stretched and let it slip past. That's exactly what happens with electrons in quantum tunneling. Strange? Yes, but not breaking physics. Quantum entanglement, faster than light communication? All right, this is a big one. Quantum entanglement. People love to say that entanglement allows for instantaneous, faster-than-light communication. Some even claim it could be used to send messages across the galaxy instantly. But does it actually work? The short answer is no. Here's the real story. Entangled particles have a special connection. If you measure one, you instantly know something about the other, no matter how far apart they are. But here's the catch. You can't use entanglement to send information faster than light. Why? Because quantum measurements are random. There's no way to control them. And without control, there's no way to send a message. Think about it like this. You and a friend each take half of a magic coin set. No matter how far apart you are, if one coin lands heads, the other will always land tails. But the thing is, neither of you gets to choose the outcome. You're just seeing a correlation, not sending information. So, while quantum entanglement is bizarre, it doesn't let you break physics. Quantum computing. Do they use parallel universes? Now let's talk about quantum computers. You may have heard that quantum computers work by tapping into parallel universes to solve problems in multiple realities at once. Sounds epic, but nope. Here's what's really happening. Quantum computers use superposition and interference to process information differently from classical computers. Instead of tackling problems step by step, they manipulate probabilities to cancel out wrong answers and boost the right ones. They aren't literally computing in multiple universes. The many worlds interpretation is just one way of thinking about what's happening. It's not necessary for quantum computing to work. Think of a maze. A normal computer tries every single path one by one. A quantum computer sends out waves that explore all paths at once, reinforcing the correct route while canceling the dead ends. It's clever, but not magic. Conclusion. Reality check. So, what have we learned? Quantum mechanics is wild, but it's not magic. Superposition doesn't mean a particle is in two places at once. It means it has multiple possible states until measured. Wave function collapse doesn't need a conscious observer, just an interaction. Quantum tunneling isn't teleportation, it's just probability. Entanglement doesn't let us send messages faster than light, it just creates strong correlations. And quantum computers don't tap into infinite parallel worlds. They just take advantage of probability in a way classical computers can't. The real universe is already mind-blowing enough. We don't need to make it sound weirder than it is. But now I have a question for you. What's the craziest quantum misconception you've heard? Let me know in the comments, and maybe we'll bust some more myths together. Please, please, please like, comment, and subscribe. And hey, don't forget to hit that bell. Let's keep exploring the real quantum universe.